Good morning, class. This is Mr. Eggleston, and this is Algebra 2 Midterm Review Part B. This is Unit 2, because your midterm is on Unit 1 and Unit 2. So this is about solving systems. So the first question is simply solve the system of equations shown as a solution of x, y. Okay, so basically lots of words. Oh, okay. So the question is, if this is a system, right here, this system, and they want to know, knowing that system, what is the value of 3x minus 2y? It looks a little daunting at first, but basically, if you just add these two equations together, if we just squish them together, you would get x plus 2x is 3x. You would get y plus a negative 3y as negative 2y, which is exactly what they want you to solve. What is the value of 3x minus 2y? And if you add 10 and 12, you get 22. So the answer is 22. Okay, a little bit weird, but you had, again, these questions are a little bit more thinking, all right? Next one is just simply solve the system. Okay, remember how I told you when we do this, that on my tests, you will only have nice solutions, all right? It turns out one of these two, because 2 and 3 are both solve the system, the answer comes out to be a decimal. And it works for this system, it is the answer for this system, but on your midterm, you should not have any decimal solutions. And since I'm saying this, I'm going to double check. I'm going to go back through them, make sure. So anyway, we're going to solve this system. Well, the first one looks to be pretty straightforward. All you have to do is use substitution. Take this y and put it in there. So we got 6x plus 3, parentheses equals 5. The parentheses is y. Y is this. I'm going to use a different color. So let's use that. So y equals negative 2x minus 4. I just took that and plugged it in there. So solving this, going through the steps of solving a slightly complicated linear equation, we have to combine like terms, get rid of parentheses. So first thing I'm going to do is distribute. Boom, boom. Something you should be very familiar with. 6x minus 6x, and then 3 times a negative 4 is negative 12 equals 5. Notice the 6x and negative 6x cancel out, and you're left with negative 12 equals 5. This is false. This is not true. All the variables are gone. That's the key. All the variables disappear. There's no x, no y, and you have a statement stating that negative 12 equals 5, which is false. This is no solution. Okay, the system is inconsistent. On your final, you will have to know inconsistent. Inconsistent and consistent. Inconsistent is no solution. So whenever you come across something, a system that's no solution, you say inconsistent. All right, let's solve 3. 3 is the one that's going to come out to be a decimal answer. So negative 5x plus, now remember, this is perfectly set up for substitution. So inside the parentheses, what used to be y will now be what the first equation says y is, which is negative 5x plus 2. And that's going to equal 38. Okay? So you got negative 5x. Now 3... distribute 3 times negative 5, 3 times 2, that's negative 15x plus 6 equals 38. All right, that's the first step of simplifying the left. Now combine like terms. Negative 5 minus 15 is negative 20x plus 6 equals 38. So negative 20x equals 32. X equals 32 divided by negative 20. Again, that's an ugly answer. As a decimal, that works out to be negative 1.6. All right. Now I'm just going to take that and plug it in for y in the top equation. Y equals negative 5, parentheses, that's x, plus 2. But we found x to be negative 1.6. So I'll plug that in. And then when we simplify, negative 5 times a negative 1.6 is actually just a simple number 8. Use a calculator, plus 2, and that's 10. So our solution as an ordered pair, okay, would be negative 1.6, comma, 10. Okay, it's a decimal, the 1.6, but it's not an ugly decimal. But again, I don't like doing that to you because kids freak out when you see decimals when we're solving systems. The only time you should see a decimal in any system solutions that I give you would be if it was a word problem and you're talking about cost of something, and so you would round to cents. All right. We're going to skip 4 because, that's not going to be on your test. It's not that hard, but it's not. Let's look at 5. CC and Owen. CC I'll call C, Owen I'll call W. All right? Because I don't want to use O because it looks like a 0. Our coworkers are comparing the number of hours they are scheduled to work next week. CC is scheduled to work 3 times as many hours as Owen. So C equals 3W. All right? So C and W are the hours that CC and Owen both work. All right? Combined, C plus W will equal, what is that, 24 hours? They are scheduled to work a total of 24 hours. Well, this is a simple substitution. Plug C equal to 3W into the second equation. You have 3W plus W equals 24. Combine like terms. Divide by 4. And you get 6. So how many hours is Owen scheduled to work? Well, since W is the number of hours Owen works, Owen is scheduled for 6 hours. Don't just say 6. At least put 6 hours. All right? Use units because they gave you units. All right. Number 6. Okay. Let's see. All right. So number 6. Jalen and Joseph are brothers who are each saving money for a car. So the 2 lines shown in the graph model the total amount of money Y that Jalen and Joseph each have deposited into their savings account X weeks after opening the account. How much money does Joseph deposit each week? So we have to look at the Joseph graph. Joseph graph is this line here. So you could see that you can go from 100 to 200, right? The change is 200. So how much money does, okay, so they're actually asking for the slope each week. This is week, and this is money, okay? So we're looking for the slope. M equals, it's rise over run. So looking at Joseph, we start down here at 100, we go up 1, 2, we go up from 100 to 200, so that's a change of 100 divided by 2 weeks. Okay, that equals $50 per week for Joseph. Write a system of equations to describe the scenario. Well, the first equation would just be the y-intercept of 100 for Joseph plus the $50 per week times the number of weeks. All right, that's just slope-intercept form because I'm looking at Joseph's line here, and you can see that the y-intercept is 100 and that the slope was 50, so it's a simple thing to write. For Jalen, his y-intercept is 150. So we know for Jalen, it's y equals 150 plus. Now we have to find the slope of Jalen. Jalen starts at 150, goes up 50 and over 2. So the slope for Jalen, I don't know how to spell it. It's going to be up 50 over 2. which is $25 per week. Oops, sorry, I was going to put a dollar sign there. So it's 25x. So that's a system of equations, right? The how much money they make per week is the slope. So we found from the first part, Joseph made $50 per week. We had to figure out what Jaden's weekly salary is, which is $25, but he started with $50 more. So, but that's your system. You could solve it. And if you were to solve it, you would see that the point of intersection is 2, 200. Interpret this point. After 2 weeks, the brothers both saved $200. Okay. A television network is creating the weekly program schedule for the TV fall lineup. There are 2 different types of programs: comedies, which I'll call C, and dramas, which I'll call D. The comedy programs are 30 minutes each, and the dramas are 60. The network needs to schedule 168 hours. So the first thing you have to realize is that 30 minutes is 0.5 hours. All right, you have to turn 30 into 0.5 because it's in minutes, not hours. And dramas are 1 hour, so it's 60 minutes, which is 1 hour. So we can write a system that says 0.5C plus 1D must equal the total of 68? Yeah, 168. That's the hours. Now they said the network schedules 230 programs. So that would just be C plus D is 230. And that's a system, and this is number of programs. So that's a system of equations that you can solve. So how would I solve this? I would probably just multiply the top equation by -1 and add it to the second equation. And if I do that, you would get negative from here, from this times that is -0.5 plus 1 is 0.5. So we get 0.5C, 0.5C. And then I'm killing the D's. So you see -1 times 1D is -D, and -D plus D is 0. So there's no D. And then we just have to figure out what -168 plus 230 is. All right? So this equals, I'm just combining all the terms. So -168, I gotta erase that. I'm just doing it on my calculator because why not? 168 negative plus 230. Oh, I hit the wrong button. 168 plus -230. 8, right? Was it 238? 230, oh my gosh. 230 gives you 62. And so when you divide by a half, you get 62 times 2 is 124. There's 124 comedies. Now, once we know there's 124 comedies, we can use that in the bottom equation to solve for D. Okay? So D is just 230 minus 124. And 230 minus 124 is 106. So there's 124 comedies. How many of each type? 124 comedies and 106 dramas were scheduled. I hope that made sense. Now, 8 is solving a system of linear inequalities. You basically graph a line in shade. So we're going to graph the intersection line, the boundary line of the top inequality. So I'm just going to imagine that as y equals 3x minus 5. So 3x minus 5 means it has a y-intercept of negative 5. It goes up 1, 2, 3 to the right 1. Up 1, 2, 3 to the right 1. Up 1, 2, 3 to the right 1. All right? Now, we're going to connect it with a line, those dots. But notice, this is a less than, so it needs to be a broken line. Now, what's nice about Desmos, or Desmos, sorry, whatever this is called, I'm blanking on it. Notability is once I draw the line, I can change that to a dashed by changing the style. So there it is. You could also use the eraser and just erase parts of it. And since you're on paper anyway, if you draw the line, just erase part of it or just point to it and say dotted or dashed, okay? But we're not done. Once we graph the boundary, we have to know which side to shade. Now, I got into choosing a point, but that seemed like almost impossible for some students because you would just choose a point like 0, 0 and check it, and you try 0, 0 on this line, and you would realize you'd end up with 0 is less than negative 5. And you're supposed to say, hey, wait, no, so that means you have to shade the other side. I'm going to now tell you another way of doing it, which is when it's written in slope-intercept form like these are, if it's a less than symbol, you shade below the line. So notice, that's a less than symbol, so we're going to shade below the line. So for this, the shading's down here, okay? Now, let's graph the other line. Y equals 1/3 x plus 1. So there's the y-intercept. We go up 1 to the right, 3. Down 1 to the left, 3. And that's about all we can do. So, wait. Up 1, 1, 2, 3. Down 1, 1. Why is that? Oh, that. All right. So we go from here to there. I'm doing this so I can just move it down. Now, this line is solid because it's less than or equal to. That means we include the boundary. So now it's less than, so we just shade below. So this is shaded below. And where the two shadings overlap, which would be in this region, right there where the red and black overlap, and that's the solution. Okay? That's the solution. Not this piece up here, because that's not shaded. That only solves the black inequality. And nothing over in this region, obviously, because that only solves the red inequality and not the blue or purple. All right, so the next one is I skipped that because that's optimization. That's something I wanted to do, but I was afraid we were losing too much time. Part number 10 is a extra credit question on your test, but I'm just going to go ahead and do it so that you can just get it into your head, because you should know how to solve systems of 3 equations, 3 unknowns. All right? It's not that bad. I'm going to use elimination. So my thought is simply, if I look at this, I know I can kill the x's and y's right off the bat by just adding those two equations together. So if you do that, you get 2x plus a negative 2x is 0. 5y plus a negative 5y is 0. And then 3z plus z is 4z. So by adding the top two equations, you end up with 4z equals 20, because you have to add the right side, right? So that's 20, so z is equal to 5. Well, now we can substitute that into the bottom equation and solve for y. 6y plus z, but z is 5, equals 23. Subtract 5 from both sides, xy equals 18. Divide by 6, y equals 3. Okay? So you got 5 and 3 as the y and z. Now we can plug it into either the top or the middle equation, either one of these. Now, I don't like the negative signs because all those negative signs, kids will screw up when they try to evaluate it. So I'm going to plug it into the one that doesn't have any negative signs. And it's up to me. If you want to use the middle equation, you could. So we got 2x plus 5y, but remember, y was 3, plus 3z, but z was 5, equals 34. So we got 2x plus 15 plus 15 equals 34. 2x plus 30 equals 34. 2x equals 4. X equals 2. And you have the solution of this system of 3 equations, 3 unknowns. Turned out not to be too bad. 2, 3, and 5. And that's it. That's the end of this because there's nothing more. I skipped this because this is optimization. It's fun and it's kind of neat, but we're not doing it. All right. So, and that was the review for the second part of the midterm. Thank you.